and welcome to another video of Mastering Arduino from Beginner to Core Advanced. In this video, we are going to talking about wireless communication using a RF remote and transmitter and receiver. Okay, let's just first come to the hardware. This is a RF transmitter which runs on 415 megahertz. Okay, and this is the RF receiver, which is a 4-channel device. Here you can see that there are 4 buttons which indicate that it is a 4-channel device. Okay. Now, let me tell you about the theory of it. It works on the principle of communication between the radio with the help of radio frequencies at a fixed frequency of 415 megahertz. Here you can see a dial which is red painted. Here you can see that this dial can be adjusted so that the transmitter and receiver frequency can be matched, and to give a proper matching function, you can rotate it. Okay, here you can see, first of all, get the pin diagram of it. Here the first pin is for ground, the second is for 5V power, and the next 4 pins are for each channel communication. Okay, it gives a 5 voltage output when the button is pressed and the communication is completed. Okay, to see its working, first of all we are going to open Arduino. It's opened, and go here, go to examples and check the digital read serial. Here I am connected the board at pin number 5, so I am going to test it at pin number 5. Let me upload it. It's uploading. Wait for a second. It is taking some time to upload. And it's uploaded successfully. Okay, let's just see it. Whenever I press the button, I can see 1 is coming. You can see here 1 0 1 0 1 1 0 1 0. Okay, whenever I press the button, the signal is completed and it sends the signal a 5V output to the digital pin 5 of the Arduino and gives a signal of high. Okay, but let us test a program here. I am going to open an Arduino sketch here, and first of all we are going to define the pins. Okay, give a pin mode. We have connected it on pin number 5, so say pin number 5 comma input INPUT, pin number 5 input. Okay, and the LED is connected on pin number 13, so we are going to say pin mode. Say pin mode, pin number 13 is output. Okay, pin number 13 is output. Okay, here write a simple program of if statement. If, first of all, for holding a value we need an integer, so we are going to call it int x is equal to, let's say, 0 for proper function. And before writing if, we need something for holding the value. Say x is equal to digital capital R EAD digital read, say pin number 5. Okay, now here write an if statement. If x is double equal to, for giving comparison we are giving 2 equal to 1, then we are going to write the statement digital write, say 13 is equal to HIGH. 13 is giving high output. For, let's say, DELAY, delay 1 second, for that we can see the working of the system properly. And we are giving an else statement as if the x is equal to 0, then the system will be low or LED will be turned off. And there should be no delay in the else statement because it will cause a problem. Okay, just upload the sketch to the microcontroller. We are giving it name REMOTE remote control. You can find the sketches at the beginning of the module. You can download it and work as your own ways. As you're required, you can work on the sketches I am giving you at the beginning of the module. Okay, let me compile it and upload it to the board. I have successfully uploaded. Okay, whenever I press the button high, it's giving me the LED as output. We can do one function here. We can get the serial output of it so that we can get a clear vision of what is going inside the microcontroller. Serial dot begin 9600 Okay, let's just do an experiment, say 115200. Only just for the sake of an experiment we are doing it. It is not necessary. And you can write the state outside if and else statement, say serial dot print the variable is x. So we are reading the variable x. Okay, successfully written, and we are going to upload it to the board. It's uploading. Now you can see in the serial monitor, whenever I press the button, it's giving the value of high. First of all, I have to correct the baud rate to 115200. You can work on same baud rate 9600, but it is done for the sake of experiment. Okay, see it taking just 1 second to give the next reading, and when I leave the button for a few seconds, it is light on, but after the second is completed, it turns off. Okay, but we have 4 buttons, or you can say we have 4 channels. So let us make a program in which we can get the output from 2 buttons of the remote to give a input to the Arduino. So that we can work with 2 buttons. Well, it is easy. Just go here and say pin mode. We define pin number 4 as input. I have connected another pin to pin number 4, and go down here. Say y, declare the integer at the top, int, y is equal to 0, terminate the line. Come here, say y is equal to digital read, digital read at pin number 4. No problem, it is at pin number 4. We don't need anything else. Go there down and check it with the help of terminating the variable y and writing terminating the variable x and writing the variable y. Upload it to the board. Now we can see the state of y here in the serial monitor. It's taking y. It's connected to the bottom of the. It is connected to button number D here. You can see in the remote. The bottom button, whenever is pressed, is giving the value of y, and the top button is giving the value of x. Okay, now go here. We can read both the values of x and y. So write a simple program. Say whenever the value of x is equal to high, say pin number 13 is equal to high, and whenever the value of say if statement, again whenever the value of y is equal to high, say pin number 13 is equal to low, and give a pin number of print, say print x, and say print t. We can use this method. It is successful. And say next line, serial dot println, say println x and y here. Okay, terminate the line, compile it. It's successfully compiled. The variable \t is used to give the space between x and y. Okay, you can see here it's giving 2 values, x and y. When I press x is equal to I, and when I press y is equal to another value. Okay, it's a mistake. Write this, upload it to the board, and it's uploaded. See here. Okay, when I press x is equal to low, and when I press high, y. Okay, see the complete experiment. Again, terminate everything. Open the serial monitor. Everything is shut down, everything is low. When I press button B, it says x is equal to high and light is continuously glowing. When I press Y, it says Y is equal to high and light is turned off. Again, X is give us continuous lighting on, Y it give us continuous lighting off. On, off, X, Y. So by this method we can use the 2 pins of the remote control to control an LED to an infinitely long on state or infinitely long off state, and we can control about 4 instruments because it has 4 channels, and we are going to use the remote for controlling a big motor in the later videos that is going on in the next module. So please watch it, and if you have any question you can ask me, or else thanks for watching. Okay, let me give you a complete summary of the what we have learned. RF communication runs on 415 megahertz. It is a 4 channel button because it is a 4 channel remote because it has 4 buttons. The transmitter and receiver frequency is measured by this rotating this potentiometer dial here, and it works on 415 megahertz. It can use to control lights or any instrument, lights such as motor, everything. For Arduino we have to use it as digital read for the input pins to get the value and process it further, and it can only give the value in the form of digital such as low or high, which is 0 and 5 volt, and we can use multiple pins in the same Arduino to control multiple objects And here in the code, let us see the code. Okay, we have defined two pins as pin number 4 and 5, and for that we have two variables as x and y here, and an output is taken as pin number 13 as LED, and we have called a serial monitor at 115200. Let us try it at 9600 for the sake of experiment. Here x for reading 5 at detail read, y for reading 4 at detail read pin number 4. Statement is simple. If x is equal to high, then LED will glow. If y is equal to high, then LED will not glow, and there is no need for this any else statement. Here you can see it will first print x, then it will print y. If you want the distance, you can just simply add serial dot print. There is no need to put ln, give two braces, and the most simple method is to simply give the space, and if you want more space, use \t for getting more spaces, but we are using simple spaces, no problem. Terminate the line, check the code, upload it once again. It's successfully uploaded. As you can see here, you can see the problem because we have changed the baud rate. Go up and you can run it on both the baud rates. Now you can see the spaces difference between x and y. When I say x is equal to high, you can see here light is glowing on. When I say y is equal to high, you can see the light is glowing off. It can run for infinitely long until the y is satisfied, and it can be shut off for infinitely long time until x is satisfied. Okay, this was the summary of the video. If you have any question, you can ask me, or else thanks for watching.